Now we are back for the video solutions of basic numeracy. This will be the same format as I have provided the video solutions for divisibility and remainder. So what I will do, I will try to discuss each and every question so that you can refer this video wherever you have any doubt in these questions. I hope that you have already attempted these questions. So it will be a go-to file for you to like cross-check your methodology and your methods and your answers. Answers I have already provided in the back of this document, but just to make sure of the methodology that you are using is fine, and the way you approach the question is feasible. Okay. So let us start from the very first question. I've already discussed this in the live class, but in this recording, I will take all the questions as suggested by some of the students. Okay, see, what we need to do in maths questions, like I have already tell you in reasoning, we need to draw the diagram. In maths, we have to form equations. Equations, what do you mean by equations? Equations mean that we have to translate English into language of maths, because we cannot like do operations directly in English. We have to translate the question given in English to the question given in to the language of maths. Okay, now here how we will do this? There are some sign symbols to use them. The sum, that means plus a and b is more than c and d taken together. This means nothing but a plus b is greater than c plus d. Okay, the sum of income of a and c is same as that of b and d. That means a plus c is equals to b plus d. A simple equations. A earns half as much as the sum of income of B plus D. A is equals to B plus D by 2, whose income is highest. Now, this is equation 1, this is equation 2, this is equation 3. Now, when we put this thing here, because B plus D is common in both these equations, now we have to find some common in both these equations. B plus D is common in both these equations. So from 2 and 3, we can see that 2a is equals to a plus a, can be written as is equals to a plus c. Okay. Now we can from here infer that a is equals to c. Now a is equals to c. When we put this in this equation, in the equation 1, we'll find that b is greater than d. And because A is an average of those things, that means A is between some between B and D. That means B is the highest. B is the highest. I hope you get it. This equation. Then the common between the equation 2 and 3, we found that A is equals to C. Then putting it in the equation 1, we found that B is greater than D. And from this equation 3, we know that A or C, that is equal to C, is between B and D. It is not greater than B and D both. Okay, something like that. Now, in 100 to 300, see in these counting like questions, and my focus in today's session is about line of thought, because there is a variety of questions that is being asked from this section, and many type of questions are there. So we, for each type of question, we must have a line of thought. Line of thought means the first thought that arises in your mind when you look at the questions. So whenever you look at this counting type question between 100 and 300, just break it into hundreds. How you will break it into hundreds? From 100 to 199, from 200 to 299. Okay, now all these numbers, these are 100 numbers, beginning with 2, beginning with 2. Okay, now if from in this number there is no number beginning with 2, but there are 102, 112. There are 10 numbers ending with 2, ending with 2. That means our answer is 100 plus 10 is equals to 110. These questions are simple. The line of thought is that just break it into hundreds. That makes your work easy. Just break it into hundreds and look at them differently. Look at them separately. That is the way. Now, in this question, what you need to do is that when C is multiplied by D, as I've already told you, for any number of digit like 1, 2, 3, into 4, 5, 6, the last digit will be 6 into 3, that is 18, 8. The last digit will be the last digit of the multiplication of the last two digits. This is a line of thought when whenever you see such kind of multiplication in variables, like the numbers are not given directly and ABC is given instead of numbers. So you can cross check it whenever you multiply any number, it is like this: 6 3 the 18, 8 carry on 1, 6 2 the 12, 13 carry on 1, 6 1 the 6, 7. So it's this 738, this 738. After this, you put a cross here, and after the multiplication, you put a cross here. This 8 is directly reflected in the final answer. This 8 is final to the multiplication of these two digits, 6 and 3. This is reflected in the final answer. This is reflected in the final answer. This is the logic that we will use to check this question. Now, what is happening here? What is happening here? C into multiplication by D is given us the last digit as C only. That is C multiplication D is giving us C as the last digit. That means D is equals to 1. D is equals to 1 because only in that case it is possible. Only in that case it is possible. When you look at the option, if D is equals to 0, then the last digit will be 0. If D is equals to 2, then the last digit will not be C. Only and only if D is equals to 1, last digit is possible. So our answer is from C and D. Now, when you can either try to put and check it like something like this 1001 into ABC, you will find that the answer is ABC, ABC. You can either check it using multiplication or by putting one or two, or by if you are aware of basic mathematics, then you can go it by logic also that it will be zero only because for two it will be a very large number. Okay, this is how you will approach this question. Now this question is a repeat from the divisibility questions that we have done. Now, if 1063 is leaving a remainder of 3 for all these numbers, that means 1060 should be divisible, 1070 should be divisible, 1080 should be divisible, and 1180 should be divisible. That is the first line of thought about remainder. Now, if we are taking about this, either we can go by LCM because this is a common question of common remainder. So, in question of common remainder, or common divisibility, what we use is we use an LCM. This common multiple should be a multiple of LCM as well. So the LCM of all these numbers is 180, and out of all these numbers, this number is a multiple of 180. First tariqa. Second way, you can go by individual divisibility test. For example, for 3, for 6, the number should be divisible by divisible by 2 as well as 3. For 3, the sum of digits should be divisible by 3. The divisibility rules that we use, no, we can use it here, apply them here. So in this 10606 plus 17, not divisible by 3. 1 plus 7 plus 1, not divisible 8, not divisible by 3. Only this option is divisible by 3. Same goes for 9. When we call for 9, the number should be divisible by 3. Same goes for 9, the number should be divisible by 3. Or the similar in the similar manner, sum of digits. So that will give us the required answer. Now, in this case, the sum of two positive integers is 52 and their LCM is 168. What is the ratio between the numbers? So, see, this is a typical question where LCM is used. Now, LCM is nothing but a multiple. LCM is nothing but a multiple. So, if we are able to find the factors of 168, then we can go for this uh, then we can apply this condition to find our actual answer. Now, when we factorize 168, when we will divide it by 2, it is 84 into 2. When we will divide by 3, it will be 56 into 3. When we will divide by it by 4, it will be 42 into 4. It is not divisible by 5 because the last digit is not 0 or 5. When we will divide it by 6, we will get 28 into 6. And when we will divide it by 7, we will get 24 into 7. Now, these are the factors. These are the factors for 168. Okay, now this cannot be possible because 84. Now, what is happening? The numbers a plus b is equals to 52. The numbers, sum of the numbers is 52. Now, 84 cannot give us some 52 because it is greater than 52. This can also not give. Now, 42 plus 10 is 52, but 10 is not a factor. Now, we are left with these two numbers. Now, 24 plus 28 is equals to 52. So, these are our required number. By hit and trial only, we have found our required numbers. By hit and trial only, we have found the required numbers. Now, when we go for the ratio, we know that 7 into 6 is equals, 4 into 6 is 24 and 4 into 7 is 28. That means the ratio will be 7 is to 6. That will be the ratio will be 7 is to 6. This is how you find the ratio. You just cancel out the common multiple, and when we will deal with the questions of ratio and fractions, this will get more clear. But this is how you find ratios. If you just need to go for a table, find the table and find the multiple for the table of 4, 6, position is acquired by 24 and 7th position is acquired by 28. That is how we find the ratio. After reaching this question seems easy. You can go for that. Now again, this is about there are five hobbies: photography, yachting, chess, electronics, and gardening. The gardening groups meet every second day. It's something like this every second day. The electronics group meets every third day. That means after gap of 2 days. The chess group meet every fourth day. That means after gap of 3 days. The yachting group meets every fifth day. That means after gap of 4 days. Something like this. And photography group meets after the gap of 5 days. This is the required problem. Now, how many times they the group meet? Now, see how will you see? Now, this is the how they are finding the common day for each of them to meet. Now, what will be the common day? As I've already told you, the line of thought is that whenever you need to find a common divisibility, common remainder, common day, or something like that, there is only one concept, that is LCM. Now, when you will find the LCM of 2, 3, 4, 5, 6, the LCM of 2, 3, 4, 5, 6, I'm leaving it to you. This is a very easy thing to do. So, LCM is 60. I will tell you the LCM is 60. How will you find that? By taking, see, it is done something like this: 2 is equals to 2, 3 is equals to 3, 4 is equals to 2 into 2, 5 is equals to 5, 6 is equals to 6, 2 into 3. Now, what will you take? What will you do? You will just take out take out the higher powers of 2. So how many powers are there for 2? Four powers are there. One is for 5, so it will be like 5 into 3 into 4. That means 2 into 2. So this is how you will get. One power is this, one power is this, that is common in 3, and one power of 5 is this, and power of 3 is common in 2. So that the our LCM will be 5 into 3 into 4. That means 15 into 4. That is 60. This is how you find the LCM. This is how you find the LCM. After finding the LCM, the question seems very easy. How many times they are meeting? How many times they are meeting? We have 180 days, and they are meeting at the 60th day. So 180 divided by 60, we will get our answer as 3. So this will be our answer. This will be our answer for this question. Okay. Similarly, the same question is very similar. Same question is very similar. So the question is about seconds. Now the LCM of 6, 7, 8, 9, 12. I want you to do it by yourself. You have done it in class also. The LCM will be 504. Now, in an hour, they are asking. So, in an hour, how many seconds are there? 60 into 60. That means 3600 seconds are there in an hour. That is a very simple logic that you all know. 1 minute is equals to 60 seconds. 1 hour is equals to 60 minutes. So, 1 hour is equal to 60 into 60 seconds. That is a very simple logic that we all know. Now they are meeting at the common interval of 504 seconds, and total we have 3600 seconds. Now when you will go it like that, 504 into 7 is equals to 3528, and 504 into 8 is greater than is greater than 3600. So this will be the case. So they will meet 7 times. They will meet 7 times based on the above logic. Now in this question there is a catch. There is a catch. What is the catch? Is that they have not mentioned us the at time equal to 0. When this all things started, have they short that also, or it is not given? So the answer given by UPSC officially was 2. So 7 and 8 both can be the answer of this question. If you will go by the LCM logic, then 7 will be the answer. But if we assume that they will have the first common shot at t is equals to 0 seconds, like at the initial, at just the starting of this thing, they will have a shot. So then this answer will be 8. So there is no common answer, and UPSC accepted this mistake and given both as answer. In such kind of question, in such type of question, whoever attempted the question will get a reward. If you have not attempted the question, then you will not get a reward. So please keep this in mind. Please keep this in mind. Now this is a very recent question. This is a very recent question. Sum of three consecutive integers. Now there are two ways. There are two ways to do this question. There are two ways to do this question. One way can be whenever you need to take three consecutive integers, you can take them in this form: three x minus one plus x plus x plus one. Okay. the sum is equal to product x minus 1 into x plus 1, something like this. And when you will solve this equation, so 3x is equals to x into x minus 1 into x plus 1. Now, for one solution for this should be x equal to 0 because x is common in both sides. Another solution will be x square minus 1 is equals to 3. X square minus 1 is equals to 3. X square is equals to 4. X is equals to plus minus 2. X is equals to plus minus 2. That means the common integers are minus 1, 0 and 1. Minus 1, minus 2, minus 3 and 1, 2, 3. These are the possible cases. For this thing, and so therefore our answer will be only 3. Now, what other way is hit and trial? What other way is hit and trial? Hit and trial. You just have to go for the see. You just need to check the basic minimum integers, because for the larger integers, for example, 4 plus 5 plus 6. 4 plus 5 plus 6 is 15. But 4 into 5 into 6 is a very big number. It is 120. So there is a huge gap between the sum and the product. So this is the second largest integer. So there is a huge gap. So we just need to check with the basic minimum integers. Basic minimum integers, that means 1, 0, 1, 2, 3, and 1, minus 1, 0 and 1, and the negative minus 1, 2 and minus 3. So these are the only ones you are going to check, because this, see, when it comes to natural numbers, this is true. This was also a PYQ. When it comes to natural number, for this it holds true. But for integers, we have to include 0 as well, and we have to check for the negatives of these numbers as well, if that case holds. So this you can go by hit and trial also, or this is the conceptual way to deal with this question. It involves some kind of algebra, so it you may find tricky. And see, this was kind of a new pattern questions where the only one, only two, something like this statement, such possibilities was asked. So this was a new, and this can be repeated in new exams of UPSC as well. Okay. Now this question, see, this you just need to know one thing. This is a combination of numeracy. These kinds of questions are very common, very much common, and these are the questions which are a combination of numeracy and permutation and combination. See how it works. So this is a number of this form. Now x and y are 0 and non-distinct. See how many non-zero digits are there? 9 non-zero digits are there from 1 to 9, and these are distinct. This means no repetition. Now, no repetition. See, either if you know about permutation and combination, so there are two places. This position can be occupied by 9, and if the numbers are not repeated, that means if one position will be at there, so this position can be occupied by eight numbers, and the answer will be 8 into 9. That will be 72. So this is the method by permutation and combination. However, we can do it in a by imagination also. Now see, if first digit is so suppose x is equals to suppose x is equals to 1. Suppose x is equals to 1. Now y is equals to 2, y is equals to 3, 4, 5, 6, 7, 8, 9. How many are there? 8 digits are there, because 1 cannot be repeated and 0 is not a part of the system. 0 is not a part of the system. For every number, similarly for 2 also, for 3 also, for 4 also, for every number we have 8 possible second number. For every x we have 8 possible y's. So how many x are there? 9x are there from 1 to 9. So for every x we have 8 possible y's. So what we will do? We will add 8 9 times. We will add 8 9 times. That nothing. It is nothing but 8 into 9, and that also will give us answer 72. So either you can go for basic permutation and combination if you are aware of that. But even if you don't know, then there is no chance in leaving such questions. You just need to have the power of this imagination and just try to imagine the thing, like for every possible x there are 8 possible y's, and we are not doing nothing but adding them all, and adding them all means then multiplying them 9 times. Okay. This is a question of data sufficiency. It is done in case like that. Now see, P is prime and Q is composite. P is prime, Q is composite. Now assume any two numbers for which this holds true. This is done only by the art of assumption. This can be done only by the art of assumption. Please bear with me. The best way to do such kind of question is to assume. And you will always find something that so now C, P and Q can be an odd number. See, P is prime. Let's suppose P is 5 and Q is composite. Let's suppose Q is 9. Okay. Now 5 9 is 45. That means the odd number. First statement can be true. Now Q by P can be a prime number. Suppose Q is equals to 15 and P is equals to 5, and 15 by 5 is equals to 3. 3 is a prime number. It can also be true. Now P plus Q can be a prime number. P plus Q can be a prime number. See, 3 is prime. Let it's P. 4 is Q. That is composite. Now 3 plus 4 is equals to 7. It is a prime number. So all the statements can be true. So but you just need to assume a number and check that if it holds for that. That is the only possible way or the shortest or the smartest way to deal with such kind of questions. Now in this question, a two-digit number Q is the number consisting of same digits written in reverse order. That means XY, and YX. The P into Q is 2430. What is the difference between P and Q? Now see, one way to do this thing, one way to do this thing is to find the difference or the reversing of this thing. But the best way or the simplest way to do this thing, the best way or simplest way to do this thing is to check for all the 91, 19. It's something like 82, 28. Something like this. So this hit and trial will give you something that is 54 into 45. 54 into 45 is 2430. 54 into 45 is 2430. So the difference is 9. This I want you to do with hit and trial, something like this, 7337, and check for this thing. See, 49, 45 is the difference. 45 is the difference between 94 and 49, something like that. So you will have to check with this thing, and that's how you are able to do this question. This question is tough. I would say this question is tough, but the best way to do this without, because if you would apply any other method, no, you will get more confused. So just try to bear with this fact that just try to gauge the things that are being reversed. So what is the difference between 9? If what you will find the number by 18 also, by 27 also, by 45 also. You'll find four numbers. So this can be 45 and 54. Now this can be I would say 36 and 63, something like that. So you will find the numbers in this way. No, 18 is not possible. But try to find the numbers in this way: 19, 19. 49 and 94. 49 and 94 will give you a difference of 45, but that does not multiply as 2430. Something like this, and that's how you can do. Otherwise, there is no easy way to do these kinds of questions. Okay. See, this question is quite easy, I would say. See, non-distinct zero digits are there. Non-distinct zero digits are there. That means you cannot include zero. The sum of x is a possible three-digit form number without repetition. Least value. Now, when we are going for the least value, now we are going for the least value. Three-digit number. What are the least three-digit non-zero numbers? That means one, two, three. These are the variables. These are the variables for the three-digit numbers, smallest three-digit numbers. So what will be so what are the chances other numbers? 1 2 3 1 3 2 2 1 3 2 2 3 1 2 3 1, something like this, 3 2 1 3 1 2. These will be the number. Now when you will add all of them, you will find that the answer will be 1332. So the least value of x is 1332. Least value, how you are determining the least value? You are taking the least number. So that's how you are determining the least value. You are taking the least number. So this is what we are. This is what we are doing. We are taking the least numbers to find the least value, and that's how we are emerging. Now, see, greatest value of x. X cannot have a greatest value in three digits because the least value is a four-digit number. So this cannot be true. So the answer will be one only. This is how you do the data sufficiency questions. Just assume, assume. This is the ground rule. Assuming how we are reaching that minimum, we are assuming the thing. Now for uh, 13, see if x is an integer. Now we have to find out x is an integer. Now we will assume 2x. Let x will be 1 by 3. 1x, it will be, let's say 1. Let's say 1. Let's say 1. Now we will put both these numbers. We will put both these numbers in. the statements and we will try to find out if it holds for both. So we will have to check if the statement is true for integer as well as non-integer, then the statement are not sufficient as to tell that x is an integer. So x by 3 is not an integer. Obviously 1 by 9 is not an integer and 1 by 3 is not an integer. Statement 1 holds for both. Statement 2 3x, obviously 3x equals to 1 and 3. So both are integer. Both of the statements are holding for both fraction as well as integer. So that's why from both these statements we cannot tell that if x is a fraction or x is an integer. So this is how you assume. This is how you assume. You will assume one fraction and you will assume one non-fraction that is integer. And if the statements are qualifying for both of them, then how can you judge with the statement that is the true for integer or fraction or something like that? So this is how you will do such question. This is also an easy question I already discussed in 2022 paper discussion. We have also taken up this in class also. Now, what I want you to do is that just try to break this number. Just try to break this number. 4 is nothing but 2 square. This we all know. 8 is nothing but 2 cube. This we all know. Now, 4 to the power of 18, you can write it as 2 to the square to the power of 18. That means 2 to the power of 36. It's as simple as that. Similarly, 2 cube to the power of 12 will also equal to 2 to the power of 36. Now, 2 to the power of 40 is obviously less than 2 to the power greater than 2 to the power of 36. That is now this number and this number are equal, and UPSC does not gives us two options. This number is we have already established that this number is larger than these numbers. So this will be our answer. Or by the basic of common knowledge also, 4 to the power of 18 will be greater than 3 to the power of 21 because it when you will look at the figures, no 4 square is 16 and 4 and 3 square is 3 square is basically 9. So there is a huge difference in the power. So when you will go for 18 and 21, we will find that 4 to the power 18 is larger. So this is how this can be done. Now this question can be done on the basis of multiplication. This question should be done by options. See, these are the line of thoughts that we need to develop by ourselves. By just looking at the question, we should know that how to do this question. Just see the number, certain numbers multiplied by 7, and and we are going to find the smallest number. We will start with the smallest number. This will be the smallest. This will be the smallest. Now, third option will be, so this will be our order: first, second, and third. This will be our order, and when we will multiply it by 7, our answer should be in the form of 1 1 1 1 1, something like that. So I just want you to do it by yourself. This will in the third case it will satisfy. See, 15873 multiplied by 7. 7 threes are 21. 1 carry on to 7 sevens are 49. Uh, plus 2 51. Carry on 5. 7 eights are 7 eights are 56. 56 plus 5 61. Carry on 1. Carry on 6. 7 fives are 35 plus 6 41. Carry on 4. 7 1 is 7 4 11. So this is how you do. This is simple multiplication. No rocket science in this. This is simple multiplication that we learn in school. Just multiply it by. I'm not using any trick. I'm not using anything, and it just took me like around 10 seconds or 20 seconds to multiply this number. So this is how you will do. See, we don't need tricks to do things fast. We just need to practice to make things fast in the usual way that we are doing since our childhood. The people who are not from math background, there is only one difference is that they learned maths in school in earlier classes, but then they didn't practice it. And the ones who went into engineering, they had some kind of practice with that. See, the difference between a two-digit number and the number obtained by interchanging the position. This is nothing but reverse. As I've told you that the line of thought for this reverse thing. The line of thought for this reverse thing is that whenever you find a reverse, you will understood this thing that, and the difference is also there. Now we know that the difference is xy minus yx should be a multiple of 9 into y minus x. 9 into y minus x or x minus y, that is a catch whenever you multiply it anyway. Now this difference is 54. This difference is 54. This difference is 54. 54 is equals to 9 into y minus x. 9 into y minus x. 9 into y minus x. So from here we know that y minus x, the difference of the number is 6. The difference of the number is 6. Now, the difference between the two digits can be determined. This we have already determined. It is 6. So, statement 2 is true. The sum of two digits of the number can be determined only if the product of two digits is no. It doesn't make any sense. It doesn't make any sense. We will not be able to determine the sum of two digits. We only have a formula for difference. This is the only way possible. So our answer will be 2 only. See, this is how you do the things that for them. Please, in this case, I want you to trust me. If there is a thing, if there is a thing that I am not teaching you, please try to think that it might not be possible to do that also, because I am covering my whole ground for basic numeracy from different sources, from all the books that I have referred for maths in my entire life. So if something like this is given, so this cannot be true. This cannot be true because this is not feasible. If it would have been true, then we have done it in class also. So this kind of confidence I want to have in you guys. Okay. Now some of the five consecutive integers. Now how to approach this kind of question? How to approach this kind of question? This will be done by art of assumption. This will be done by art of assumption. This will be done by art of assumption. Now see, when you will divide 100 by 5, when you will divide 100 by 5, you will get 20. You will get 20. Now, I have already told you, whenever you need to find three consecutive integer, whenever you need to find three consecutive integer, you will take them as x minus 1, x and x plus 1. Similarly, for five consecutive, what we can do, we can take it as x minus 2, x minus 1, x, x plus 1, and x plus 2. So these will be the five consecutive integers. Now, how you will find your x? By dividing 100 by 5. This is how you will find your x. This is, I'm just asking you to assume. Now, from this case, you will find that 18, 19, 20, 21, and 22. These will be the five consecutive integers, and when you will add them, you will find the sum as 100. This is how you will assume. This is how you will assume. You will just divide 100 by 5 because it is asking about five consecutive integers. And when you will break them in this order, and when you will do the sum, so this will be the assumption, and this will be the true. The sum of five consecutive integers can be 100, can be 100. How to find these five consecutive integers? And see, this was a question about can. This was a question about data sufficiency. This was a question about statement. But in next year, what it may ask us to find those five consecutive integers whose sum is 100. That's why I am doing this solution in this way. So this can be true. This can be true. For in actual exam, you just need to say that it is true or not. It can be true. The sum of five consecutive integers can be 100. But how to find those five consecutive integers? You will divide 100 by 5. You will get 20, and the two integers 18, x minus 2, x minus 1, x, x plus 1, and x plus 2. These five integers will be there whose sum will be 100. This is how you will find 18, 9, 18 to 22. These will be the five integers. Okay, the product of these. So this is the this we have already seen. 1 into 2 into 3 is equals to 1 plus 2 plus 3. This is how you will assume, and this is how you will check the answer. Okay. Now these kind of question are already discussed in class, but I think that they might have bothered you. They might have bothered you, and this is a very typical way of asking questions by UPSC. This is a very typical way of asking questions by UPSC. So I want you to understand it carefully. I want you to understand it carefully. Now see, this is nothing but see, suppose you are adding numbers like this 3p, 4p, pp, and pp. Now, when you will add p four times, the last digit is 2. When you will add p four times, when you will add p four times, when you will add p four times, the last digit is 2. The last digit is 2. This you have to keep in mind, and that's how we will find p. So we know that 2 into 4 is 8. 2 into 4 is 8. That means this cannot be our case. 3 into 4 is 12. The last digit is 2 in this case. So P can be 3. P can be 3. First case. Similarly, we will find that 8 into 4 is 32. The last digit is 2. That means P can also be 8. These are the only two possible values. I want you to check by other numbers also, like 5 into 4, 6 into 4. You will find that the only possible values for P are 3 and 8. Now try to put p when you will put p is equals to 3. When you will put p is equals to 3, you will find that r is equals to 1 and q is equals to 4. That means rq2 is 142. First number is this. First number is this. When you will put p is equals to 8, you will find that r is equals to 2 and q is equals to 6. rq2 is 262. Now you need to find the average of these two numbers. Let me tell you the basic about average. C, if C is average of A and B, C is equals to A plus B by 2. C is equals to A plus B by 2. This is the simple concept of average. We will learn it in later classes, but for the sake of this class. So when you will find the average of 262 plus 142 by 2, you will find that the answer will be 202. 202 will be the answer. This is how you will approach this question. Let me summarize it again because this approach will come very handy. Please learn this approach. If the variables are given, just try to find the last digit. Try to match with it with the last digit. When you multiply, adding 4 times, that means multiplying by 4. Adding a number 4 times means multiplying the number by 4. See, p plus p plus p plus p is nothing but 4p. 4 into p. Okay, so adding a number 4 times means multiplying it by 4. On the basis of that, we will try hit and trial to find the possible values of p, that in this case will be 3 and 8. For each value, we will find this number RQ2. For 1, it will be 142. For 8, it will be 262. And then we will find the average of these two numbers to get to the answer. To get to the answer, this is the approach. Okay, this question also have some similar approach. This question also have some similar approach. This question also has some similar approach. So what are you doing? After multiplying q into 3, we are getting q again. So it is only possible when you will go for hit and trial. No, you will find that it is only possible for 5. It is only possible for 5. 5 3s are 15. The last digit is q in case of 5. In case of last digit is for 5. For 4, it is not possible. For 6, it is not possible. For any number, it is not possible. This is possible only for 5. We'll assume that q is equals to 5. Now, after knowing that p into 5 into 3 is equals to r 5 5. This is how you will do this. Now what we need to do, we'll have to again go for hit and trial for p and r. We will again have to go for hit and trial for p and r to find the values of p and r. So when we will go for a hit and trial, we will start with 25 into 3, that is 75. It is a two-digit number. It is a two-digit number, so we will negate this case. Proceeding in this way, we will reach at 85 into 3 is equals to 255. 85 into 3 is equals to 255. Now this is matching our case. In this case, P is equals to 8, R is equals to 2, and Q we have already established that Q is equals to 3. So this equation P plus R divided by Q will give us that 8 plus 2 divided by 5. That means 10 divided by 5. That means 2. So our answer will be 2. This is how you will do. I want you to do these hit and trials by yourself because that will be a lot that will take a lot of time and there is no conceptual understanding. I just want you to try and check it by yourself by different numbers. I will already tell you what will be the case. Now this 20th question, okay. See, consider the three-digit number obtained using three non-zero digits, which are multiples of three. Which are multiples of three? What are the three digits? What are the three digits that are multiple of three? What are the three digits that are multiple of three? 3, 6, and 9. These are the three digits that are multiple of 3. Okay, that S be their sum. So what we will do, we will create the digits using these three numbers, multiples of three, that is 3, 6, and 9. First multiple, second multiple, and third multiple. And then we will check for these. Then we will check for these things. Then we will check for these things. So what you will do? 369, 396, 639, 693, 936, and 963. These will be the these will be the numbers. These will be the numbers. When you will add them all, you find S will be equal to 3996. Try to do it by yourself. Try to do this by yourself. S will be equal to 3996. Now you will have to check the divisibility of 74 and 9. Now, how you will check the divisibility of 9? You will check the divisibility of 9. Just add the digits. Add the digits. 9 plus 3, 3 plus 6 is 9. 9 plus 9 plus 9 is 27. That summation of the digits is divisible by 9. That means statement 2 is true. Now, there 74, we don't have any divisibility rule. Now, when we don't have any divisibility rule, what we do? We will divide 3996 by 74. We will try to divide it by like that. So, when you will go for division, so 74, when you will go for division, so you will find that 74 into 54 will give you this number. I want you to perform this division by yourself. I want you to perform this division by yourself, and that will be a very good thing if you can do it by yourself. Now, see, suppose something like this. How you can proceed? You can proceed it like this. See, 74 into 5 is nothing but 370. You will get a 29. Now, 296, 296, 74 into 4. 74 into 4 will give you 296. So this is how you will find. This simple division, I want you to perform it again by yourself. Now we know that this is also divisible by 74. So both statements are correct. This is the way to proceed these questions. What we have done, we have just found the initial multiples of 3, single digit number, 3 digit number is the multiple of 3. We have created all the three digit numbers possibly. We have taken their sum. The another question in year 2022, the 1 to 3 wala jo question tha, that was also a similar on similar lines of this. So this is how the question is repeated. Exact question will not be may not be the same, but this is how the question will be repeated. Okay. Now this thing, integers listed from 700 to 7,000. Again, this is a counting question. Again, this is a counting question. We will break 700 from 700 to 799, 800 to 899, and 900 to 999. This is how you will break. This is how you will break. Now, for this number, the first digit is 7. The sum of digits should be 10. So how it can be possible? We know that 7 plus 3 is equals to 10. So this can be either 703, 730, 712, 721. These are the four digits that are possible for 7. Similarly, we know that 8 plus 2 is 10. 8 plus 2 is 10. It can either be 802, 820, 811. These three digits are possible for 8. These three digits are possible for 8. Similarly, for 9, it can either be 901 or 910. So, how many cases are there? 4, 3, and 2. 4 plus 3 plus 2 is equals to 9. 9 possible cases are there for the sum of digits to be 10. This is how you proceed. This is how you proceed. Now this question, I want you to do it by yourself. This is a tough question. I would say this is a tough question because to check that the number is prime all for all the numbers, it is quite a tough task. But now I just want you to give the numbers. The numbers are 223. Just check that these numbers are prime or not. Check that these numbers are prime or not. 227 and 229. These are the four numbers that are prime. You just see, just check the odd numbers. First rule, just check the odd number. Second rule, check for the divisibility test of all the numbers. As I've already told you, just you need to find the square root of the number. You just need to find the square root of the number. You just need to find the square root of the number. Okay. So the square root will be around nearly maybe 14 and 15, between 14 and 15. 14 is 196 and 15 is 225. So the square root will be between 14 and 15. Just check for the prime number, check for the divisibility of the prime numbers till 14 and 15. This is how you will get, and these four answers. But this is a very lengthy and very tricky or very tough question, I would say. In exam like condition, you should not do it in the first go. You should, if similar question is again repeated in the same pattern, then we will be doing, but we won't be doing if there is no other way of doing these questions. Okay, for 23. See, again, same thing. P and Q are two distinct two-digit number consisting of the same. See how many times this concept is repeated. Check this pattern. Check this pattern. How many times this question is repeated? This pattern is repeated, and UPSC in different exams is asking on the same line. Now this is nothing but P and Q. Let P is equals to XY. Let then Q will be the reversing of digit. That means YX. Now we already know that P minus Q, that at XY minus YX is 9 into x minus y. So the number is divisible by 9. The number is divisible by 9. If you know this concept, then this question is very easy. But if you are not aware of this concept, this is hardly a conceptual question. This is a very hard conceptual question. If you are aware of this concept that I have already told you, then you can do this question in a very easy manner. But if you are not aware of this question, then there is no going back. There is no going back. Okay, now I have already discussed this 24th question. Again, this question should be done in that way only. Again, same way. Xy minus yx. Similar pattern. See how much pattern this pattern is repeating. S minus y, x minus y. Now this is 27. So 27 is 9 into x minus y. We know that x minus y, that is the difference of digits, is 3. Now we are aware that the difference of digits is 3 on the basis of our concept. On the basis of this concept, we know that the number of digits is 3. Now what we do, we need to find the numbers. The numbers will be 14, 25, 36. We are just the sum of digits should be 3. 36, 47, and 58, and 69. These are the numbers. We will just add them and we'll find that the answer will be 249. You just need to add these numbers. 14 plus 25 plus 36. We just need to add these numbers. We'll find that the answer will be 249. Now this number 1 multiplied by 2940 becomes a perfect square. This is how you will do this. We will go for the prime factorization of 2940. We will go for the prime factorization of 2940. In this case, it will be 2 square into 7 square into 3 into 5. Try to do it by yourself. I've already told you how to do prime factorization. This will be the prime factorization of, so see, this is a square, this is a square, and this is 15. 3 into 5 is 15. So there is only one 15. If you multiply it or divide it by the same number, the number will become a perfect square. This is the logic. This is the logic. When you will do the prime factorization, no, you will find that there are even powers and odd powers. Odd powers. Even powers are square. Even powers are square. Even powers are square. Similar in this case, 2 square, 7 square. Even powers, or if it is 2 to the power of 4, then it is 4 square. So even powers are always square because they are divisible by 2 and they can be converted in the form of square. Odd powers are not square. Odd powers are not square. Odd powers are not square. Sorry for the pencil disruption. Odd powers are odd square. So either you will multiply the number with same odd power so that the power becomes even, or you will divide the number so that the remaining number is left. So if you multiply it by 15, it will become a perfect square. Or if you will divide it by 15, so the question can come in a division form also. So if you will divide it by 15, 7 square into 15, then also this remaining will be left. That was already a perfect square. That was already a perfect square. So even though both by dividing and both by multiplying, you can reach the same result. Now this question can be, so there are m and n multiple positive integers that they are greater than one. How many possible values of m and there? So now what we need to do, we need to break 72 into factors. We need to break 72 into factors. And I've already told you this was the same question with 168 in a similar question. So how you will break? You will just divide it by 2, 2 into 36. Then we will try to divide it by 3, 3 into 24. Then we will divide it by 4. So it will be 4 into 14, I guess. So 14, okay, 15, 16. Is it divisible by 4? 18, 18. Then we can go for further divisions as well if we want to, but that is not required if we don't want. And 8 into 9, 8 into 9 is also there. 8 into 9 is also there. And uh, is there any other possibility? Is there any other possibility? Is there 12, 12, it is divisible by 12, no? 12, 12, 6, 6 into 12, 6 into 12. So these are the possibilities. These are the factors. You divide it by 2, 3, 4. You can divide it by all the single digit numbers and try to find the possibilities. So these are the only possibilities. So 5 will be the answer. Only this is the only way to do this question. Like just try to divide it and try to find all the possible factors. Now 27th question. 27th question. The average of 7 consecutive odd integers number is m. If the next 3 odd numbers are also included, the average, what will be the average? So this is the question. Again, we will use the assumption. We will use the art of assumption. We will take the first 7 odd consecutive integers that are 1 plus 3 plus 5 plus 7 plus 9 plus 11 plus 13. Okay, 7. First 7, we will take the first 7 consecutive integers. We'll get the average as, 49 by 7, that is 7. We got the average as 7. This is how you find the average. Now, when 3 odd integers are added, that means 49 plus 15 plus 17 plus 19. Now it will be divided by 10 because now there are 10 integers. It will be 100 by 10, that is 10. So the average has been increased by 3. There is increased by 3. Now, let me tell you a fact based on this thing. This is how you will done it by, you will do it by this thing. Now, if you have observed this thing, when there are 7 odd consecutive integers, the average is 7 for the first integers. For 10 odd consecutive integers, for the first 10 odd consecutive integers, the average is 10. This is how you do the thing. The average of first n consecutive integers is n only. This is the learning from this. This is the learning from this question. The average for n consecutive integers is n only. Is n only. Okay. Now this question we have already discussed, but I just want you to do this thing. So this is something like 4x3 plus 984 is 13y7, and this 13y7 is divisible by 11. This 13y7 is divisible by 11. Now how we will do that? So we will apply the divisibility rule of 11. So what will 1 3 by 7? What was the divisibility rule? This is 1 2 3 4. We will take the sum of odd position 3 7 plus 3 minus y plus 1 or minus even. We found it that this is 10 minus y plus 1. It should either be a multiple of 11 or either should be 0. So we got that y is equals to 9. When we will put that y is equals to 9, we will find that x is equals to 1. X is equals to 1. So the sum of x plus y is 10. The sum of x plus y is 10 based on the two fundas that are given in the question. Okay. Now again perfect square question. Again perfect square question for 2880. For 2880, it will be 2 to the power of 6 into 3 to the power of 2 into 5. Now this is the prime factorization of 2880. This is the prime factorization of 2880. This power is even, this power is even, only this power is odd. So either you should multiply it by 5 or you should divide it by 5. In this case, it is asking for division. In this case, it will asking for division. So if you multiply it by 5 or you will divide it by 5, this will become a perfect square. So the answer will be 5. Same question, similar lines, no change. This is how you read the repetitive pattern. This is how you read the repetitive pattern. Okay, now let's see this question. Sum of two numbers is 143. Okay, so a plus b, let us suppose two numbers, the sum is 143. The greater number is divided by the difference of the numbers, the quotient is 7. When the greater number is divided by the difference, that means a is equals to 7 into a minus b. A is equals to 7. That when a is divided by the difference of a minus b, then the quotient is 7. And we know that division is equal, dividend is equals to divisor into quotient plus remainder, and there is no remainder. The number is divisible, so remainder is equals to 0. So on basis of this, we have written this. On the basis of this thing, we have written this. What is the difference of the two numbers? Now we have to find the difference of two numbers. See, now in this case, from this equation, we know that 6a is equals to 7b. 6 is equals to 70. When we put it in this, so we will put it as a, a plus 6 by 7 of a is equals to 143. 143. 143. That means 7a plus 6a is equals to 143 into 7. That means 11a is equals to 143 into 7. So we will get it as a as 143 into 7 by 11. A is equals to 77. This is how you will get, because this will be 11 into 11, no? What's 11 square is 6, sorry, 13, 13, 13. Sorry, 13. This is, sorry for the mistake. Uh, this is how I make mistake when I do things to very fast. So this will be 143 into 7. So A is equals to 143 into 7 by 13. So this will be 11. A is equals to 77. A is equals to 77. A is equals to 77 based on this calculation. And when we put it back in that, A is equal B is equals to 60. We will find that B is equals to 66. So the difference is 11. So this is a calculation RD question. This question is very some kind of calculation is required. But the question is this. So what are you doing? You are just converting the English language in the language of maths. This is how you do it. These are the two equations. Based on these two equations, you try to find the value of one variable, and then you will find the value of other variable. This is a question that is calculation heavy, and this should be done in that way only. Okay, how many times will the digit 5 come in counting from 1 to 99, excluding those numbers which are divisible by 3? Excluding those numbers which are divisible by 3. So this is how you do. See, there are many ways to do these questions, but I just want you to calculate it using normally. So the first number where 5 will come is 5. The first number where 5 will come is 5. Then 25, 15 is divisible by 3. Then 35. Uh, then again, it will be 45 is divisible by 3. Then we can go for 51 is divisible by 3. So sum of digits. Sum of digits. Just check the sum of digits. For divisibility by 3, there is no need to go for the table of 3. Just check the sum of digits. 51 is divisible by 3. 52 is not divisible by 3. Then 53. 54 is divisible by 3. 5 plus 4 is 9. Then 55. 56. 58. 59. 65. 75 is divisible by 3. 85 is not divisible by 3. 95 is not divisible by 3. and 50. 5050. I forgot this. So how many numbers are there? So 3 plus 3, 6. 6 plus 3, 9. 9 plus 4, 13. 13, and you know that 1555, there are two fives, so the answer will be 14. This was the catch. This was the catch. 13 was also in the answer. 13 was also in the answer, but the 5 comes two times in the number 555. So that is the catch. This is a simple counting question, and I want you to do it like this only because there is no other way of other simpler way to do this question. Okay, this is a typical question that is often repeated. A device can write 100 digits in 1 minute. Start writing natural numbers. The device is stopped after writing for half an hour. For half an hour, it is found that the last number is incomplete. The last number is incomplete. The last number is. See, this is how you find the digits. This is how you find the digits. See, half hour means 30 minutes. Half hour means 30 minutes. In 100 digits in 1 minute. 100 digits in 1 minute. How many digits in 30 minutes? 3000 digits. 30 into 100. 3000 digits in half hour. In half hour. 3000 digits. 3000 digits it can write. Now how many digits? How the digits will count? From 1 to 9, 9 digits are there because they are single digit numbers. From 10 to 99, 10 to 99, 90 numbers are there and 2 digits are there. So 180 digits. 180 digits. From 100 to 999, this is the only way to proceed, and this is a very repetitive question, and I want you to note it down. From 100 to 999, so 900 numbers are there and 3 digits are there. 3 digits are there. So total 2770 digits. Now when you will add these, now you will add these. Now when you will add these, now sorry, when you will add these numbers, you will find it that this is 2889. This is 2889. This is 2889. Now, so total we have 3000 digits, and we have already reached 2889. Total we have 3000 digits and we have already reached 2889. Okay, now when we start from 1000, so we have to check is it either 26 or 27. So let us check 26. 1026. Let us check 26. 27 digits are there and 4 are there. 27 digits are there. 27 digits are there and every 27 numbers are there and every number contains 4 digits. So the answer will be 27 into 4, that is 108. 108. So 108 digits will be more required to write 27 digits up to 1026. So then you will add 2889 plus 108. It will come 2997. It will come 2997. Now it will come 2997. So 2997 digits, using 2997 digits, we are writing till 1026. We have three digits left. Three digits left. Digits left when the machine stopped. The last number it was writing was incomplete. This number is 1027. We have three digits left. See how we are doing this. From 1 to 9, there are 9 numbers at 9 digits because every number is single digit. From 100 to 99, 10 to 99, there are 90 numbers and 2 digits. So that means 180 digits will be typed. From 100 to 999, there are 900 numbers and 3 digits each. That means 2770 digits will be there. Now you will add these numbers up till 1000. For thousands, for to write up to 1000, you will require, for 999, you will require 2889 digits. Now, how much more than 1000? So we'll check till 1027. If it either it can be the answer or 1027 is the answer. Okay. Now when we will check it for 1026, we found that 27 digits are there, 27 numbers are there, and every number contains 4 digits. Every number contains 4 digits. Okay. So 108 digits are required to do them. Now adding 108 into this number 2889, we get 2997. That means we have 3 digits left. We have 3 digits left. So the last number that was the machine was writing and that was incomplete should be the next number. That means 1027. That means 1027. If this number would have been more than 3000, that means the answer would have been 1026. This is how you will proceed in this kinds of question. And this is standard procedure. A book typing these kind of questions are very repetitive in UPSC. This is the standard way to do attempt these questions. Just go for the digits, the number of digits, and attempt it like this. How many times the digit 5 will come in counting 1 to 9, excluding those which are divisible by 3? Same question. Same question. Same question. It is in CISF. This question is in CAP. This is question of UPSC. Is of UPSC CSE. So this is same question. Exact same question. Exact same question. This is year 2014, I guess, of UPSC, and this was of CSAT. If three times of the first of the three consecutive odd integer is three more than the twice the third, what is the third integer? So this is how you do first three odd integers. First three odd integers are x. First of the three consecutive odd integers. Consecutive odd integer. How you will take consecutive odd integers? See, I already told you how to take consecutive integers. X minus one, x plus one. So what are odd integers? Alternative integers. Odd integers are alternative integers. In that case, what we will do? You will do x plus two, x plus 4. These will be the three consecutive odd integers. Three consecutive odd integers. Now, it is given in the question, the first of the three is three more than twice the third. What is the third integer? Three more than twice the third integer. See, it is something like that. 3x is equals to 2 into x plus 4 plus 3. This is the third integer. This is the first integer. It is three times of the first integer is three more than the twice of the third integer. So this is the equation that we have got. This is the equation that we have got. Based on this equation, we will get that. Based on this equation, we will get that. Basically, x is equals to 11. Basically, x is equals to 11. See how we are doing this. 3x is equals to 2x plus 8 plus 3. X is equals to 11. This is how we are doing this. X is equals to 11. Now x is equals to 11. Third integer will be x plus 4. That means 15. Third integer will be x plus 4, that is 15. Okay, this is how you will do these kinds of question. When the square of the sum of two numbers are added to the square of their difference, we get 416. The difference between the square of the sum and the square of difference is 384. See, this is a typical algebra kind of question. You don't need to worry this about CSAT. This may not come in CSAT, but for the sake of it, what is this? The square of sum of two numbers, that means x plus y ka square. The sum added to the square of their difference, x minus y square, we get 416. We get 416. 416. That means now x square plus y square plus 2xy. This is the formula for x plus y square. Then x square plus y square minus 2xy. This is the formula for that thing. So 2 into x square plus y square is 416. First thing, 2 into x square plus y square into 416. Then difference will be x square plus y square plus 2xy minus x square minus y square plus 2xy. This the difference will be 4xy. The difference will be 4xy. So 4xy is equals to 384. Based on this thing, we will get that 2 into x square plus y square plus 2xy is equals to adding these things. We are not nothing but adding these things. We'll get it as 800. So x square plus x plus y square plus 2xy is equals to 400. This is nothing but x plus y whole square. That means x plus y whole square is 400. X plus y is equals to 20. X plus y is equals to 20. So x plus y is equals to 20. This is only possible in this case of 8 and 12. Although this is a question of algebra and this is a lengthy question, if you are not able to grasp it, don't bother about it. This will never be repeated in CSAT as per my intuition. And if this will be repeated, this will be the toughest question of that year. There are some questions that are out of context and are tough. I just have kept it because it was a part of list of CISF exam questions. But this is a way of doing this thing. If you know about the formulas of this square, you will be able to grasp it. But if you are not able to grasp this thing, then there is no need to worry because this is not the part of that. So for those who want to attempt this question, I have given the solution. So this is how you will proceed for this question. In writing all the integers from 1 to 100, how many times the digit 1 is used? Now this is a question which this is again a question of counting. This is again a question of counting. This is again a question of counting. I want you to do it by yourself. The answer will be 160. The answer will be 160. I want you to do it by yourself. This is a question of counting. How many times the digit 1 will be used? This is a question from counting. Consider sequential integers from 23, 7 to 93 be both included in the sequence. The arithmetic average of these numbers. Now see, how you will find the arithmetic average of these numbers? So let me just give you the fact. The integers are also AP. Integers are also AP. Integers are also form an arithmetic progression. Integers also form an arithmetic progression. For the sum of arithmetic progression is number by 2 upon first plus last 27 plus 93. Okay, number by 2 27 first plus last, and average is sum by number. Average is sum by number. So based on these two things, you will know that average will be equal to 27 plus 93 by 2, because this n will be cancelled. 27 plus 93 by 2, that means 120 by 2, that means 60. So this is a very easy question if you are aware of this concept. This is a very easy question if you are aware of the concept of AP. See, don't bother about the question number 20, 35 and 37, because these may not be repeated in the same way in CSAT exam, but if it comes in another way of some other writing, this is how you will proceed. The sum of AP is the sum of first digit and last digit multiplied by the number by 2, and the average is s by n. From this formula, s by n is equals to first plus last by 2. First plus last by 2. This is how you will do. A palindrome is the number which reads the same from left as well as right. What is the number of palindromes between 10 and 1010? Number of palindromes between 10 and 1010. Okay. Now how you will do it like this. So see, for two digit number, two digit number, AA is palindrome. For two digits number, AA is palindrome. Okay, I hope you get it. How many types of AA are there? Well, 11, 22, 33. So 9 are there. 9 are there. First thing, 9 are there. For three digits number, A, B, A are palindrome. A, B, A are palindrome. What? 121, 131, 232, something like this. How many numbers will be there? 90 will be there. 90 will be there. 90 will be there. And one number it will be for four digit number 1001 will be a palindrome. 1001 will be a palindrome. So this will be last. So 100 palindromes will be there. This you can check how they will be 90. How they will be 90, because two places are fixed. Two places are fixed for A, and this number can vary. This number can vary. B can vary. Okay. So this is how you will 9 into 10. 9 into 10. 90. This is how you do it. This is how you do it. Don't worry about this thing. If you want to count also, you can count. How you will count? How you will count? Just count palindrome from 100 to 199 and multiply it by 9. Multiply it by 9. You will find that there are 10 palindromes between from 100 to 199, and for same case will be repeated from 200 to 299. Same case will be repeated from 300 to 399. So just multiply. If we will multiply it by 9, then we will get our answer. So there are 90 palindromes for three digits, and for four digits there is only one palindrome, 1001, up till 1010. Okay. How many pairs of natural numbers are there such that the difference of whose squares is 63? Okay. So see, this is the thing. This is the thing. A square minus B square. So this is a year 2020 question. A square minus B square is A plus B. This is an important formula of algebra that is very handy in numeracy also. A plus B into A minus B. Now what the difference of square they are giving us as 63. The difference of square they are giving it as us as 63. Now 63 is equals to A plus B into A minus B. So 63 can be written as 9 into 7. It can be written as 3 into 21. It can be written as 1 into 63. These are the factors of 63. So three such pairs are there. Three such pairs are there. You can find different values of A and B based on these factors, but three such factors are there. Three such factors are there. Okay. Again, 40th question. See, this question is sum of digits. Sum of digits. For 10, what is the value of power of 10? 10 to the power of 1 is 10. The sum of digit is 1. 10 to the power of 2 is 100. The sum of digit is 1 plus 0, that is 1. Sum of 10 to the power of 3, the sum of digit is 1. So for any value of 10, any value of power of 10, any power of 10, the sum of digit is always 1. So if you add 1, the sum of digit is always will be 2 for any whole number, for any whole number, for any whole number. Okay, so this is how you will do this question. This is a very easy question, very easy question. Okay, now largest number. See, this is the minus power. One thing you need to know that if uh, so 2 to the power of minus 1 is written as 1 by 2. When the denominator have a power, when denominator have a power, it is written as minus. It is written as minus. This question is trying to confuse you. This question is trying to confuse you. This question is trying to confuse you. This is a similar question that we have already done. This is 2 to the power of 6. This is 4 to the power of 3. This is 3 to the power of 4. This is 6 to the power of 2. Now, now 3 to the power of 4, 2 to the power of 6 is 64. 4 to the power of 3 is 64. 6 square is 36. 3 to the power of 4 is 81. So this is the largest number. This is the largest number. You just need to calculate. You just need to find. You just need to find, and this is how you will do. And again, two options are same answer. This cannot be true. 6 square is very small, 36. So this is how you do. This is a very simple question of counting. This is a very simple question of counting. The answer will be 6 to do it yourself. 43. R is greater than P as well as Q. Two statements are there. PQRS is followed. Among the first one, which one is largest? This is a question of arrangement. This is the question of arrangement, but this is question given in number form. R is greater than P. R is greater than P as well as Q. R is greater than Q. S is not the largest one. S is not the largest one. So S is not the largest one. That means R is also greater than S. R is greater than P. R is greater than Q. R is greater than S. That means R is largest. R is largest. Both statements are required. Both statements are required. R is largest, and both statements are required. Okay, because first statement does not tell us anything about S. First statement cannot that do not tell us anything about S. Okay, again data sufficiency question. Again a data sufficiency question. See, will you do it using assumption? As I've already told you, we'll do it using assumption. Statement one is that n is a prime number. Statement two is that n leaves a remainder one when divided by four. When divided by four. Okay, if n is a unique natural number between 10 and 20, what is n? Now, natural number between 10 and 20, how which number leave a remainder 1 when divided by 4? When divided by 4, 13 leaves a remainder 1 when divided by 4, 17 leaves a remainder 1 when divided by 4. Okay, 13 leaves a remainder 1 when divided by 4. 17 leaves a remainder 1 when divided by 4. 13, n is prime, that means 13 is prime. 17 is also prime. So both these numbers are satisfying both the equations. That means we cannot tell either the number is 13 or the number is 17. We cannot tell this thing. So both statement S1 and S2 together are not sufficient to tell us is the number 17 or 13. We cannot go for the unique number. Okay. Now this question, 45th question. So the S1 and S2 are given numbers, required to two numbers followed by this thing. Their product is 21. So when you break 21, that is 7 into 3, 21 into 1. There is no other breakage. The sum is 10. The sum is 10. Now 21 plus 1 is not 10. 7 plus 3 is 10. 7 plus 3 is 10. So based on both equations, we can tell that what will be the answer. See, in year 2020, the numeric questions were asked in form of data sufficiency and assumption, or this kind of assumption or this kind of presence of mind is required to solve these questions, and this can repeat again. This can repeat again. Okay. There are not more than two figures on any page of a 51-page book. Not more than two figures. Not more than two figures. But there can be one figure also. There can be one figure also. Suppose the maximum figures are two. The maximum figures are two. In that case, 51 into 2, 102 figures will be there. 102 figures will be there. 102 are there more than 100 figures. But there can be a case where 40 pages have only one figure and only 11 pages have two figures. That means in that case we will have only 62 figures. So the number is less than 22, or the number can be greater than 100, less than greater than 100. So statement 1 cannot be true. There is at least one figure on every page. Still there is at least one figure on every page. Still, so even after SN together, even together they are not sufficient. Even if there is one figure on every page, even if they are one figure on every page, still there can be a case where 40 pages are one figure, and there can be a case where all pages have two figures. So in one case the answer is greater than 100, in other case the answer is less than 100. So we cannot be sure. And if we are not sure, then we will mark that statement 1 and statement 2 are not together sufficient to answer the question. are not together sufficient to answer the question. Okay, this 47th question is again based on the similar things that we were doing in 2021 year. So A3 BC plus based, so do it the way you are doing since childhood, DE2F, and the answer is 15902. 15902. Okay. Now see, there are four digits. Digits are greater than three. Digits are greater than three. So if C plus F is giving us last digit is two, that means C plus F is not two, it is 12. And there is a carry here. There is a carry here because the numbers are greater than three. The numbers are greater than three. C and F cannot be one plus one is equals to two. If the numbers are greater than 3, then either it can be 8 plus 4, it can be 9 plus 3, or well, any case, but they are giving us a sum as 12. They are giving us a sum as C plus F is giving us a sum as 12 and not 2, and a carry will be there. A carry will be there on B. A carry will be there on B. That means B plus 1 plus 2 is equals to 10. Again the same case, the sum cannot be 0. It will be it will be 10. So B is equals to 7. We have found that 7. Again, E plus 4 is equals to 9. This can be a possible case. 9 can be a case for greater than digits greater than 3. We'll find that E is equals to 5. We'll find that E is equals to 5. We found that E is equals to 5. Now again A plus D, last thing left. A plus D is equals to 15. A plus D is equals to 15. A plus D is equals to 15. Now there are two cases. There are two cases. Either it can be 9 comma 6, or it can be 7 comma 8, or it can be 7 comma 8. But see, B is already 7. B is already 7, and the numbers are distinct. So this cannot be a possible case. This cannot be a possible case. So what we are left with? We are left with 9 and 6. So the difference between values of A and D will be 3. This is how you will do. Just presence of mind. Just presence of mind. Just write this in the standard sum for form. Then just try to gauge that if a number are greater than 3, then they cannot be, sum cannot be equal to 2. So if 2 is given as the last digit, then it will be 12 and 1 will be carried. The usual way we do the summation. This is the usual way we do the summation. This is the usual way to do the summation. This is how we will do. Again, the same case, the sum cannot be 0. It will be 10 and 1 will be carried. So this is how you will find the value of E. We will find the value of B, and C plus F is 12. C plus F is 12. So for A plus D is left, we are left with 15. For 15 there can be two combination. Either it can be 7 or 8, or it can be 9 comma 7. But the numbers are distinct and B is already 7. So the answer will be A and D are 9 and 6. They have asked us the difference. So the difference between 9 and 6 is 3. Okay. Now 48. Again a booklet printing question. Again a similar question of booklet and printing. Pages are numbered in the usual way. Numbers starting from pages 1. The sum of the numbers on the remaining pages is 195. The torn page contains which of the following number? Now see. Now see. It is asking about the sum of numbers. The sum of natural numbers. The sum of natural numbers. See, the sum of natural number 1 plus 2 plus 3, suppose it is there. So it is 6. So 3 natural number, the sum is 6. And how we arrive at 3 into 4 by 2, that is 12 by 2, that is 6. So this is a formula. This is a formula for sum of natural numbers, n into n plus 1 by 2. N into n plus 1 by 2. Now the sum is 195. The sum is 195. The sum of remaining pages is 195. So when we will try for 20 into 19 by 2, we will get it 190. So this cannot be the case. This cannot be the case. This cannot be the case because this cannot be the case because the remaining pages, like the after tearing two pages, the sum is 195 and this is less than 195. Then we will proceed for higher. 20 into 21 by 2. We will reach at we will reach at 210. This can be the case. We will reach at 210. This can be the case. The sum of first 20 pages. This is the sum of 19 pages. This is the sum of 20 pages. This can be the case. 210 can be the case because it is greater than 19, and the remaining page is sum of 95. So the sum of torn page, the sum of torn page is 210 minus 195. That means 15. So we have found the sum of torn pages. Found the sum of torn pages, and from this 15, we will look at the options, and this 7 and 8 satisfies this 15. This 7 and 8 satisfies this 15. I hope it is correct. I hope Okay, now again question on the same pattern. How you'll do? You will try to find the options. So if 3 is added 3 times, 3 is added 4 times. One, 2, 3, 4. A digit is added 4 times, and when one is added to that digit, the digit becomes that itself. So what we will do? We will try to find it with 2. So 2 into 4 is 8. 8 plus 1 is 9. The digit is not 2. For we will try with 3. 3 into 4 is 12. We will add 1. It is 13. 13 means the same digit. 13 means the same digit. 13 means the same digit. This so the answer will be 3. We can check for 4 and 5 as well if you want to, but the answer will be 3. So this is how you will do. You will put it in place of this thing and you will check the last digit. So how you will check the last digit? 4 times 3 is added in last digit, and then 1 is added. Then 1 is added. So it is something like this: 3, 3, 3, 3, and then 1. So this will give you the last digit as 2, and when you will add 1, this will give you 3 as last digit. So this is the only case possible with 3. I want you to do it by yourself. I want you to do it by yourself. So how many 5 digits prime number can be obtained by using all the digits 1, 2, 3, and 4 and 5? See. Prime number. What are prime numbers that are not divisible by any number? Now see, check the sum of digits. 1 plus 2 plus 3 plus 4 plus 5. This is 5 plus 4, 9. 9 plus 2, 11. 11 plus 4, 15. 15, 5 plus 1, 6. It is divisible by 3. It is divisible by 3. That means any number formed by these digits will be divisible by 3. Any number formed by these digits will be divisible by 3. That means there cannot be any prime number that will be divisible by this number, so the answer will be 0. And this is a very tricky question that UPSC usually asks. So we have to do this in a smart way. We have to just check the divisibility or something like that, because there is no possible way to find how many five digit number. There is no possible way. There is no possible way. If we are not able to do it like this, no, there is no possible way to do this to do this question. So UPSC is very smart, and we should be more smarter than that. Okay, now this question, see, Q and S have to there we have to add something in Q and S to reach the equal level. So they cannot be the largest. They cannot be the largest. They cannot be the largest. Now from P and R we have to check. From P and R we have to check. From P and R, so P minus 2016 is equals to R minus 2018. So P plus, when you keep it here, P plus 2 will be equal to R. P plus 2 will be equal to R. That means R is largest. So it is something like 3 plus 2 is equal to 5. So 5 is greater. 5 is greater. So in this case also P plus 2 is equal to R. That means 5 is greater. R is greater. So this was a very simple question. Again, the question of trailing zeros. We have done these question. We have done this question in I guess we have done this question in divisibility and remainder. I want you to do it by yourself. I want you to do it by yourself. The answer will be 10, I guess. How many triplets satisfy the equation this? Then x, y, z are natural numbers. X, y, z are natural numbers. Okay, now x plus y plus z are 6. X plus y plus z are 6. Now, one, so 1, 2, 3 can give us 6. 1, 2, 3 can give us 6. And how many questions combinations can be there? How many combinations can be there? It can either be 1, 2, 3, 1, 3, 2. It can either be 2, 3, 1, or 2, 1, 3. It can either be 3, 1, 2, or 3, 2, 1. So 2, 3, 6 combinations are from here. 6 combinations are from here. Now 6 combinations are from here. Now 4, 1, 1, 4, 1, 1. There can be 3 combination. 1, 4, 4. Oh, sorry, 1, 4, 1, 1, 1, 4, and 4, 1, 1. There can be 3 combinations. 3. And 1 can be 2, 2, 2. This is only the hit and trial. Hit and trial. You can only do this question using hit and trial, but just try to break how you will achieve 6. Either it can be 2 plus 2 plus 2. Either it can be 4 plus 2. Either it can be 3 plus 2 plus 1. Something like this. For three numbers, 4 plus 1 plus 1, or 3 plus 2 plus 1. This is how you will break, and you will find the possible numbers. So 6 plus 3 plus 1, 10. And in such cases, you just have to arrive at the maximum option of number that is given in the maximum number given in the option. If you are able to reach that, then that will be the answer. 54, easy question. How many fives are there which are not immediately preceded by 3 but are immediately followed by only 1 is there? Only 1 is there. Again, same question. 136 is added to 5b7. The sum is obtained 73. A and B are integers. 7a3 is exactly divisible by 3. Now, see similar questions many times it has been asked in the same value. 7a3 is divisible by 3. That means 7 plus 3 plus a should be divisible by 3. 7 plus 3 is 10. Now a can either be 2 for 12, a can either be 5 for 15, a can either be 8 for 18. Okay, these are the possible values for 8. These are the possible values for a. So we have found our possible values for a. Now 5b7, 5b7 plus 136. We have to try this thing. We have to try this thing. Can it be 723? Can it be like after hit and trial? We will find that either it can be 723, 753, or 783. 783. Now, if we'll put these options in B and try to find these values with A, we find that B is equals to 8. So this is the only way to do this question, hit and try. After reaching this level, after reaching this level, after reaching this level, after reaching this level, try to put all the options in place of B, and you will find that C, 527 plus 136 cannot reach up to 7. 557 plus 136 cannot reach up to 700 Q. 577 and 587, these are the two options left, and in that also 8 will be feasible. Because see, 527 plus 136 will give us 7 6 13 ones, 2 3 5 6. So it is giving us only 600. So this is giving us only 6 in the row of 600. So we have not reached 700 yet. Same will be the case with 550. Okay. So this is how you will apply. Consider two statements, 5 S1 and S2. So what you can do to do this question in easy way, first put the values of B, hit and trial, try to find the answers, and then check with this the values of A. Then check with the values of A. Okay, that will be a bit faster, I guess. 56th question. Again, the art of assumption, P and Q are both prime numbers. Is PQ an odd integer? Is PQ an odd integer? We need to find. See, if P plus Q is an odd integer, if P plus Q is an odd integer, only odd plus odd can give us odd. Sorry, odd and even. Only an odd plus even can give us odd. Something like this. 3 plus 2 is equals to 5. Odd plus odd will be even, and even plus even will be even. Something like 3 plus 3 is equals to 6. 2 plus 2 is also equal to 4. Both are even. So odd plus even can give us odd, and we know that odd in multiplied by even is always even. So PQ is not an odd integer. Based on second statement only we can say that. Based on second statement only we can say that. With prime number we cannot say anything, but with this second statement we can say this thing. Again the question of printing of pages. Again the question of printing of pages. Similar question. Similar question. Until 999 we have 2889 digits. We have 2889 digits. We will check until 1048. 1048 we will check. So that will be 48 into 4. That means 48 into 4. Something like that. So that will be 176. Now we will add 176. So that will be 3089, I guess. Something like that. So we will reach that the answer will be 1049 for this question. Now this question was asked in CISF, CAPF, and similar question was asked in UPSC. This I want you to do it by yourself. The answer will be 1049. The answer will be 1049. Sorry, it will be 192 and 192. When we will add 2889 plus 192. 2889 plus 192, we will get 3081. 3081, and we have 3089 digits. We have 3089 digits, something like this. So, in that way, we will be able to. In that way, we will be able to do this. In that way, we will be able to do this. This will be 192, 2889 plus 192. Okay, 104. Sorry, 49. This is there. 49 into 4. We need to find no 49. 196. That will be there. 196. So 196. This will be. Yes, so the answer will be 1049. Okay, I want you to do it by yourself again. I just given you a hint. If x is greater than or equal to 25, y is less than equal to. So this is a simple question. This is 25. This is 40. So x is greater than or equal to 25. Something like this. Y is less than or equal to 40. Something like this. So this is the bracket. This is the bracket. This is the bracket that we are getting. So y minus x is less than or equal to, so either y minus x is less than or equal to 15. Maximum value of y minus x can be 15 when x is equals to 40, y is equal to 40 and x is equal to 25. Or it should be less than that. It should be less than that. This will be the answer. It is very logical and it is very easy. The ratio of two-digit number to a number formed by reversing the digit is 4 is to 7. The number of such pairs is that. See, something like this 10a plus b. How a two-digit number is represented 10x plus y and 10y plus x is equals to 4 by 7. Is equals to 4 by 7. This is when you will do it, when we will do it, we will find that 2x is equals to y. 2x is equals to y. So the number of pairs can be 1, 2, 2, 4, 3, 6, 4, 8. No more than that. So 4 pairs are possible. 4 pairs are possible. 1, 2, 2, 4, 3, 6, 4, 8. I want you to solve it by yourself. This, if you want to do it, then 70x plus 7y plus 40x, 40y is equals to 40y plus 4x. So when you will do it, you will find that 2x plus y is equals to 2x is equals to y. Okay, solve this. I want you to solve this by yourself. This will be 66x is equals to 33y and 2x is equals to y. The number of times the digit 5 will appear while writing the integers from 1 to 1000. The answer will be 300. I want you to do it this calculation by yourself. I want you to do this calculation by yourself. What do you mean when you are find three-digit number is there? One method I can suggest you if you are able to do this. But the counting method, I want you to do it by yourself. See, 5 can take the place of this place 100 times, this place 100 times, and this place 100 times. So total 5 will be repeated in 100. So this is how you will do. This is how you will do. 100 plus 100 plus 100. Because all the three-digit numbers are asked. There is no catch here. There is no catch here. From 1 to 1000, all the numbers are asked. So why can take these places 100 times? This is my method, and I want you to do it by counting method also. Okay, so 61, both x and y must be positive for value of x for any. See, x minus y is 8, then which of the following must be true? Both x and y must be positive for any value of x and y. No, this is not true. So it can be something like this: 6 minus 2 is equals to 8. One is negative, one and 2. If x is positive, y must be negative. This is also not the case. 4 plus 4 is equals to 8. Both can be positive. X is negative, y must be positive. No, that is not the case. That is also not the case. So you can do it by assumption, something like that. Numbers from 700 to 1000. How many number digits? Hundreds place is greater than the digit at 10th place. Digit at 10th place is greater than the digit at 100th place. This is a typical question. This is a typical question. I want you to do it by using calculation method, and I will discuss it in next live class. Please remember. Please make me. I want you to discuss this 62 question is a typical question, and this is a UPSC question of 2018 year. I want to discuss it in the live class so that if any doubt is there, that will resolve. The answer is 85. I want you to do it by counting method by yourself. But if that doesn't work, then we will discuss it in live class. This is one such question that I want to discuss in live class. A number consists of three digits, which is middle one is 0, and their sum is 4. Okay, so A 0 B, A plus B is equals to 4. Sum is 4. The number formed by interchanging the first and the last digit is greater than the number itself by 198. 198. The difference between the first and the last digit. See, A plus B is 4, but doesn't matter. So the reversing the digits, again reversing the digits. So A 0 B minus B 0 A is equals to 99 into B minus A. 99 into B minus A, that is 198. 198 is into 99 into B minus A. That means B minus A is equals to 2. B minus A is equals to 2. Now we know that A plus B is equals to 4. B minus A is equals to 2. And the difference is only R, so that will be 2. So this is a trick question. This 0 and all these things doesn't matter. Only this concept of reversing the digits is only thing that matters. And this is again, this is a very useful concept. Please, this repeatability of this concept is very much in UPSC exams. Please, please, please work it up, and please Remember it and please do the thing. Okay. Uh, x is minus 1, minus 3 and minus 1. Let's suppose x is minus 2. Y is between minus 1 and minus 1. Let's suppose y is equal to 0. X square minus y square is between which of the following number? Which of the following number? So if you want to do it by assumption, if you want to do it by assumption, then in this case it will be 4. So it can either be 0 to uh, so this cannot be true. This cannot be true. This cannot be true. From 0 to 8 and 0 to 9, you must know that uh, if you will take the number close to 9, if you will take the number close to uh, 3, then the answer will be 9. If we'll take x as minus 3 only and y is equals to 0, then the answer will be 9. So this is how you do it by assumption. There are other methods as well, but I want you to do it by assumption. Just take the extreme value from here, that is minus 3. X is equals to minus 3, y is equals to 0, between 1 minus 1 and 0. You will find that x square minus y square is 9. X square minus y square is 9. So this is how you will do. This is how you will do. Extreme values. X and y are natural numbers other than 1 and y is greater than x, which of the following represent the largest number? So this is how you will do. Just assume x is equals to 3 and y is equals to 2. This is again assumption. X is equals to 3 and y is equals to 2 other than 1, because they were asking which of the following xy is equals to 6, x by y is equals to 3 by 2, y by x is equals to 2 by 3, x plus y, that means 5 by 6. So only this, all other are simple fractions. This number is greater than x plus xy is greater. So this is how you will proceed. This is how you will do. Again same question. Again same question. One again will this similar repeated pattern. A number which is multiplied 3 times and then 4 is added to it becomes that number itself. So a number multiplied 3 times and 4 is added to that, that number becomes itself. So when you go for 4, so 4 into 3 is 12, 12 plus 4 is 16. The last digit does not become 4. We will go for 5, 5 into 3 is 15, plus 4 19. The last digit does not become 5. We will go for 8, 8 into 3 is 24, 24 plus 4 is 8. Last digit becomes 8. That means 8 is the answer. This is the only way to do this thing. Hit and try from the options and on the basis of the knowledge that we have. Again, the printed book question. Again, the printed book question. Simple question from 1 to 9. 9 digits. From 10 to 99. See, this question is again repeated from CISF and CAPF. They were asking tough question in that, and this question is quite easy. So 10 to 99, 90 into 180 digits. Now from 100, you can check for 150. 51 into 3, that means 153 digits. When you will add all of them, you find 342 digits are there. So that will be the answer. So this is how you will proceed. This is how you will proceed. Last few questions. There are two digit numbers. The difference between the number and one obtained is reversing is 27. How many such maximum two digits number are there? Now again 27, 27. Similar question, similar on the similar pattern will be 9 into x minus y. Just the difference between the digits will be 3. The difference between the digits will be 3. Now, how many pairs can be there? 1, 4, 4, 1, 2, 5, 6, 3, 7, 4, 8, 5, 9, 6, something like this. 6, 6 are there. 6 can be there, so none of the above will be the answer. Okay, a two-digit number is reversed. The larger of the two, again, two-digit number is reversed. Larger of two numbers divided by the smaller one. What is the largest possible remainder? What will be the largest possible remainder? This was done on the basis of options. This was done on the basis of option. This is 98 and 89. This can be 98 and 89. This can be the remainder of 54 and 45. So the remainder will be 45. The largest. So check the largest number. Check the largest number 45. Is it possible for any number for 54 and 45? If 54 is divided by 45, the remainder is 45 itself. The remainder is 45 itself. It will be 0 into 45 and the remainder will be 45 itself. Okay. So check the largest number and check for the possibility of that number. Check for the possibility of that number. If that is possible, that is the answer. Okay. Last question. How many numbers are there between 99 and 1000 such that 8 digit 8 occupies the unit place? Digit 8 occupies the unit place. That means this place is occupied by 8. 8 is fixed for this place. Now, how many numbers are there for this place? From 0 to 9, 10 numbers are there. And how many numbers are there for this place? Again, if the digits are not repetitive other than 8, then there will be 9. So 90 numbers will be there. 90 numbers will be there. 9 into 8. Or you can do it by any other means as well. There is no hurdle. You can just go for, like, select one, then go for the numbers. Like last digit is fixed at 8. There can be 10 possible combination from 0, 1, because the digit can be repeated here. The digit can be repeated here. Why 9 is there and not 10? Because 0, if you put 0 at this place, then the number will become 2 digit. Then the number will become 2 digit. So for the first position there can be 9 digits. For 10, for second position there can be 10 digits, because 0 is also included. Okay, and last digit is fixed for 8. Last digit, this is not 8 times. This is, sorry, this is not 8 possibilities. These are the 8. This is fixed for 8. That is only one possibility for last digit, and 10 possibilities for second digit, and 9 possibilities for one digit. This you can check for, if you uh, check, if you keep one at first position, from 0 to 9 there will be, from 0 to 9 there will be second, fourth position, and last position will be occupied by 8. So this is how you will get, and for every number this will be true. So total number will be 90. For total number will be 90. This is the end of this discussion. This was a long discussion because the questions are so many. There are 70 questions, and in actual exam, there are every year there are around from. These are the basic themes: divisibility, remainder, LCM, HCM, fractions, number system. One thing, that is the reverse of digits. Reverse of digits. Okay, I just want you to give some line of thought in this lecture. Line of thoughts. Whenever you see something as common, go for LCM. Whenever you see this reverse, use this 9 x minus y or 99 x minus z wala. This is the most important. This is the most important. Whenever you see counting, break it into hundreds, like 100 to 10, 199, 200 to 299. Break it like that. Whenever you see digits of books, so do it like that only. 1 to 9, 9 digits. 10 to 99, 90 into 2, 180 digits, something like this. This is the 9 digits. This is the way to do the digits of book question. And other questions are very repetitive. Other questions are very simple equations, and larger than this, greater than this, prime number, basic conceptual things are there. So they are manageable and they are doable. These line of thoughts must be in your mind while attempting the questions of basic numeracy. Thank you. Happy Hanuman Jayanti.